let's see another example. So this example says we has ideal gas. Cp of this ideal gas is 7/2R. So Cp is given. We have 1 mole of this gas confined in a piston cylinder. So we have 1 mole. This is the total amount we have. It's put in cylinder. Initially, this gas at 300 Kelvin, 0.1 megapascal. So initially, we have 1 mole at 300 Kelvin at 0.1 megapascal. If the gas is compressed isothermally, this means temperature is constant. So if the gas is compressed isothermally to 0.5 megapascal, so we have 1 mole, 300 degrees Kelvin, and the new pressure is 0.5 megapascal. But same number of moles, same temperature we have here. We need to find the amount of work, and we need to find the amount of heat associated with this one. Okay, again, so this example here is an example of open or closed process. Closed. So will we have enthalpy in the inlet and outlet terms or internal energy? What do you think? Internal energy. Again, so this one here, this system is closed. So closed means there is no inlets or outlet streams so, and this implies two things. So the first one, any term have the subscript in, it doesn't mean inlet, but this one means initial condition any term is have the subscript out again this doesn't mean outlet stream, but this implies to the final condition or the final state. So this is number one. This is the first thing you should keep in your mind when we are talking about a closed system. Again, for closed system we have no flow work. So this means we have no enthalpy in inlet and out terms. So in other words, this means we're gonna use internal energy. So whenever we are talking about or solving example for closed system, all of these things should be applied. Okay. So the energy balance equation, we have the accumulation term equal in, which is initial states, minus outs, which is final states, plus work of expansion contraction plus shaft work plus Q. So again, here he didn't mention anything of any changes with time, so there is no accumulation, so we can assume it's a steady state. There is no moving part, so there is no shaft work. So here he need to find this work, this is requirement number 1, and we need to find this work, this is requirement number 2. So start substituting this equation. So we have 0, this one, again, and we have given is number of moles. So all the equation for the inlet and final conditions will be not specific terms, but molar. So this one will be initial number of moles times molar internal energy plus kinetic energy plus potential energy at initial condition minus final number of moles times molar internal energy plus kinetic energy plus GH plus work of expansion contraction plus Q. And again, here this is the piston at the same horizontal level, so there is no change in the potential energy. we have no movement happening, so there is no kinetic energy term. So we can say from this equation we have 0 equal N is constant. The initial state we have 1 mole, the final state we have 1 mole. So in initial and the final are the same. I can take them as a common factor. So this will be N delta U plus work of expansion contraction plus Q. So far it's clear? Okay. So I need to find work of expansion contraction. So let's start with this one. So this is the first requirement. I need to find work of expansion contraction. The same equation I have here. D WEC equal minus P dV. So I can say by integration then W of expansion contraction equal integration of minus P dV. Here let's see this example. P1 is 0.1 megapascal. P2 is 0.5 megapascal. So pressure is not constant. So again, in this example here, this is very important to note this. So for the pressure, in this example, pressure is not constant, which means you cannot take the pressure out of the integration term. So you should integrate with respect to pressure. But the question, how you can integrate pressure, and your integration is with respect to volume. So there should be a relationship between pressure and volume, right? So what we have here, in this one, so work of expansion contraction equal negative integration of P dV. So since we have ideal gas, so this means PV equal nRT. So this means pressure is nRT over V. And this is the relationship between pressure and volume. So we will use this equation and substitute in the integration term. So then work of expansion contraction equal negative integration of nRT over V dV. N, number of moles, is constant. 1 mole remain the same at initial and final state. R, the ideal gas constant. It's constant. Temperature, this process is isothermal. So temperature is constant. So nRT, I can take them out of the integration. So this one will be negative nRT integration of dV divided by V. Integration of dV divided by V, so this one nRT will be ln V and limits of the integration from V1 to V2. So this one will be negative nRT ln V2 divided by V1. Or if you put the negative inside, so this will be nRT ln V1 divided by V2. Is it clear? Any questions? Okay. So the key now, I don't have the value of V1. I have N1, I have T1, I have P1. But I have no idea about what is the value of V1. Similar, I have nothing to know about V2. But again, we have ideal gas. So again, this means PV equal nRT, or we have V is nRT over P. So V1 will be N1 R1 T1 divided by P1. V2 is N2 R2 T2 divided by P2. So then work of expansion contraction, this will be nRT ln V1 nRT T divided by P1. N2 nRT divided by P2. Just because N1 and N2 the same, T1, T2 the same, I just keep N and T. So this one here, if you simplify it, so nRT, this is constant, so these will be cancelled from here. So nRT will cancel nRT from this side, so this will equal N or T ln P2 divided by P1. Start substitute. We have number of moles, N. We have R, 8.314. We have temperature, 300 Kelvin. We have ln P2 is 0.5 divided by 0.1. So if we substitute in this equation here, we have work of expansion contraction will be 4014 joule. And this is the first requirement we have. So this is how we put all the information, and then we can find the work of expansion contraction. Clear? Okay. Is it clear? Okay. So now let's recall the energy balance equation. So we have 0 equal N change in the molar internal energy plus work of expansion contraction plus Q. So now with this term, we know its value, 4014 joule. And this was requirement 1. The second requirement is to find Q. So in order to find Q, what we need to find? N is 1. And the change in the molar internal energy, right? But here note this thing. In this example, we have ideal gas. And for ideal gas, the value of the internal energy, if you remember, is function of only temperature. This is the only parameter that affecting the internal energy value for ideal gas. And in this example, this process is isothermal. He mentioned this in the problem itself. We have isothermal compression. Isothermal compression means temperature is constant. Or as you can see from this figure, T1 is 300 Kelvin, T2 is 300 Kelvin. So this one means T1 equal T2. So since T1 equal T2 here, so this means the internal energy at initial condition equal internal energy at final condition, which indicates that any change we have in the internal energy will equal to 0. So just see what is mentioned in the problem itself, because some information it listed and it tells you like an idea. Instead of wasting time with saying, okay, I need to find the change in the internal energy, so integrate CVDT. So try to go to the appendix, find the value of CV. Or here in the example, CP was given. So you know that, okay, for ideal gas, CP is CV plus R. So you will waste a lot of time. Try to calculate something that if you just see what is mentioned in the problem, you can know this parameter at the end will be 0. So whatever integration you are doing, we will end up with, there is no change in the internal energy, because this process is for ideal gas and this process is isothermal. And for ideal gas, internal energy and also enthalpy are function of only temperature. So based on this thing here, I can cancel this term. So then I can say the work of expansion contraction, this one will equal negative Q. And since I have work of expansion contraction, so then I can find Q. This will be negative 4014 joule. And this is the second requirement. Is it clear? Any problems?